Welcome to Designing Production Serverless Platforms, Startups to Enterprise and back again. My name is Frazer Jamieson. I'm a Chartered Digital Engineer. I was awarded my Chartered Engineer status by the Chartered Institute for IT. I'm a cloud and system architect. I've got 20 years experience in IT, the vast majority of it, fortunately, designing IT systems. Currently, I work at Cognizant, where I'm a principal architect in the cloud architecture and transformation practice. And I like to focus on innovation there, particularly cloud-native full-stack engineering. And in terms of things like migrations, especially re-architecting solutions to get the best out of the cloud and the most benefit. This talk really is about my journey into serverless through building serverless platforms myself, that's the startups bit, to designing enterprise solutions and noticing the real similarities in the architectural patterns, and then trying to push the envelope a little bit further and move it into public cloud integration that I'll talk about towards the end. So just a few initial points of clarity. And I'll just mention this because I'm going to put some bullet points up, and sometimes people have mentioned in the past, oh, well, I think that should have gone first and so on. Sure. Bullet points in this will just be, then it won't be in a specific order, so they're just points that I wanted to discuss. Numbered items obviously will. Also, in terms of not knowing exactly how it was going to be presented, I can't always fit everything into a diagram, although I've been very judicious with that. If there's anything that is missing, I'll voice over. And these are my personal views, so I'm not representing Cognizant or any previous employer. These are my opinions and observations. So the purpose of the talk, I'd really like to demonstrate how serverless designs really are suitable from startup to enterprise. The advantages of serverless designs that I've found in the process of designing them and seeing them deployed, lessons that I've learned, and then, as I alluded to a moment ago, the future of cloud systems. And for the definition, for this talk, I'm defining serverless as cloud-native services, and I'm only going to be dealing with Amazon Web Services and Google Cloud Platform and G Suite. So we'll all be familiar with the advantages of serverless. I'd just like to get an idea of the audience, because I can do deep dive technical or I can keep it sort of middle. So I'm going to ask about business, whether you're primarily focused on business, technical, or classify yourself as very technical. So business people in the audience first? Okay, so technical. That's quite clear. Very technical? Right, I've got to be careful. Okay. All right, great. Now, this should be exciting then. Good. So we'll know about these. No idle costs, running costs, no provisioning of servers, no operating systems. We'll all be aware of all of these. No patching, no system maintenance, no licensing costs. I like to focus a bit more on the inherent elasticity. I think that it's a real boon. And I probably don't really need to explain this looking at the raise of hands, but the fact that we're going to scale back in automatically. And I also think that I think the cloud's moving more and more to global services, and obviously serverless as it is at the moment is cross-availability zone, so you're already getting a lot of redundancy. Disadvantages, and many of you may argue with me, I can't see any. Yeah, sure, there's new skills to learn, and certainly for production enterprise systems, that's what I'm going to be going on to next. There's skill sets that need to be added into any company. But couldn't that be said of any new technology and any new service or feature? So going to cloud architecture best practice, these are the tenets I like to stick by. You'll see that they're very close to AWS's because I think AWS's are excellent. Running through them, again, I can probably skip through these quite quickly considering the audience and dive more into the architectural diagrams. But build security in every layer, every step of the design. Of course, the reason I put these up is these. I also think that these really are appropriate to serverless. So design for failure and nothing fails. I always think, what happens when this section of, the design fails? I love this one, leverage different storage options. I'm always trying to battle and work out, why can't I use S3 for this? Especially in things like caching, where you don't really need to worry about performance. And so I know that the days gone by, you put data in a database because that's what you did. But we all know now that's not necessarily the situation. And I'll show you 3 different instances where the original idea very much was to go to things like Redshift or databases, but I managed to design it to use S3 to all the advantages that S3 used, to all the advantages S3 gives you. And as a great colleague of mine would always say, automate, automate, automate. We all are familiar with that one, but I think that's really important because it forces you down the road of ensuring that everything is infrastructure as code. Self-healing systems, etc. Loose coupling sets you free. Obviously, we don't want any weak chains, links in the chain, but focusing again on implement elasticity, that's one of the big benefits as I see it. Again, a highly technical audience, so you'll be familiar with the think parallel. Why should we process things in series? It's not going to cost any more to do it in parallel. But not on the AWS one. Keep it simple. And that's what I keep learning. So the more I do something and the more these designs get more and more complex as you bolt things on, I like to sit down and go, actually, there might be a better solution to this. And that's where the end bit of this talk, when I'm talking about public cloud integration, I think there's a good illustration of that, or example. DevOps philosophy, strongly believe that it's imperative, really, in actually deploying serverless in enterprise production systems. You need those small teams working closely together. I don't need to describe the 2 pizza teams, what that means, apart from the business person. Keeping your team small enough that you could feed them lunch or dinner with 2 large pizzas. The idea with the DevOps is it's more of a philosophy and a culture. So you're trying to keep people in small teams where they've got great communication, hopefully building up camaraderie. They can address issues quickly. If you mix that with an agile environment where they're discussing blockers on a daily basis, you get to a position where you also link in small, frequent changes, multiple commits a day, where anything that does go wrong is not necessarily and hopefully major and can be fixed fast, and you can keep that pace going. So these projects can move at pace, and that's vital. But it's not just vital for money, it's vital because of that bit on the bottom there. What you really want your team to get to a point of is to be able to have the ability to learn, to communicate, to learn from each other, experiment. And when they get brave enough to experiment, obviously you're getting to the point where you can optimize these systems. You iterate on that and you're getting innovation. And so that's what I've put down there. The DevOps philosophy linked with an agile environment, you lead to automation, well, infrastructure as code, that will lead to automation, leading to pipelines, obviously serverless, and then starting to be brave with your designs. So getting on to the talk itself, where did my serverless journey start, or having a look at the architectural patterns? Because the audience is quite techie, you've probably been in the same position as me. Way back, I had some websites, and I didn't really know what I was going to do with them. But I wanted a contact us web page on there, and obviously I knew about S3 and that I could do the static website hosting, but I couldn't get that email functionality or PHP, for example. And I didn't really want to spend the £12 a month. So I started learning about what I could do in serverless to get that contact us functionality in. So obviously I started off with a static website. I started looking at different JavaScript frameworks. So I looked at JavaScript because most modern browsers, well, all modern browsers really are going to process that natively. I looked at a single page application because I knew that I was going to be using CloudFront and I would have the benefit of edge locations, so I could deliver a slightly larger file quite quickly to whoever was trying to receive it. And also, obviously then I provisioned, moved away from, when I started learning Angular, I moved away from using GitLab and started going into code commit. And then I started experimenting with Cognito. I realised that using the the JavaScript SDK, again, for those of you that may not be familiar with that, AWS will allow you to integrate a software development kit into your various applications that will allow you to access the services, certain services. Cognito, experimenting with that, I understood that I could use user tokens, but then I needed to get to the crux of the matter and get a contact us form working. So using API gateway, linking that to Lambda, and using that to the API gateway to trigger a Lambda that was just sending an email off using SNS. That was quite straightforward. I could also expand on that and get to logged in users using Cognito, and I could use authorizers on API gateway. Then I started looking at work and thinking, let's try and make it, let's start doing what I do at work a little bit more. Started splitting out the static assets, getting a higher TTL on those, and starting to put a dev environment together. So that at this point it was manual. I was making manual changes. I was checking it on my dev environment. That looks good. Manually committing it to the prod environment. But then, of course, I put in a serverless pipeline. And that was automatically on my commits, actually building the appropriate code for dev and prod. Then I started to go onto AWS Labs. I started experimenting with the stuff available on GitHub, and I saw that AWS step functions would allow me to orchestrate various things. I even started using a bit of recognition. There's some great stuff there, and I'm sure quite a few of you have used that. Has anybody, hands up on anyone that's used AWS Labs and actually done any projects themselves? Okay, so hands up if I'm going a bit too deep technically here. Or is it about right? Yeah? Okay. So with AWS Labs on GitHub, they give you some sample code, and it's a really good way of getting your hands dirty and trying stuff out. That's this bit here. I just thought I would try out AWS step functions. It works to orchestrate lambdas. I was actually using recognition, which is a bit of AI/ML there in AWS, and starting to build images that were then being stored in that static assets bucket that you can see. At that point, obviously, I was linking into CloudWatch events, so I learned about triggers, being able to work on this logic layer. And there we had it, really. I thought, okay, this is good. I've got a logic layer there, I've got a presentation layer, I've got my data layer. I thought, what am I going to do next? I'm going to start applying this to every project that I've worked on, every project that I'm seeing in my colleagues and what I'm working on myself. And what did I learn? I thought, well, get your hands dirty is fundamentally the first thing. The moment you start playing with these systems within AWS, it's very easy to bolt on extra functionality, try things out. It's very easy to keep within the free tier in AWS. And I also realised this is ideal for startups because you're going to be able to create new web applications, etc., that is going to cost the startup nothing until they're popular. And when they are, they're not really going to mind the fact that they're getting bills through when it scales up, and it's going to scale up. I also learned a lot about the ability of CloudFront to cache, not only for S3, but obviously for API Gateway. And that works really well with SPAs, single-page applications. So moving on to an enterprise solution that I was then assigned to as the lead architect. And this is for a very prestigious car manufacturer. And what they needed is, well, they weren't sure the exact nature of the particular projects that were ahead of them, but what they did know is they needed a good platform that would scale, that would allow them to receive this engineering data from their millions of vehicles in order to get to a position where they could look into the insights of this data and push innovation. This particular company, the project itself was highlighted at the AWS Summit in London this year. It's part of their connected car program. And the engineers and data scientists are really, they're world class, and they wanted to be able to have AI/ML capability as well. With this massive data that's coming out of the vehicles, They wanted to be able to see what insights they could extract from that in order to re-engineer their vehicles to be, to continue to be world class. So I put this up because now hopefully you will see how similar it is to the previous one. So I knew there was a lot of data coming out of all of these vehicles. I knew that it had to be collected. API gateway was the obvious choice. I needed ancillary services in there, so CloudWatch and SNS go in. I knew that I would need to be able to have authentication and use authorizers on the API gateway to secure it. And I used Kinesis Firehose in order to collect the data, but also to take advantage of the fact that Lambda can filter, etc., transform the data as well. So what I had to do here is design a platform that could do stuff that we weren't sure had to be done. So serverless kind of fit that profile very well. I knew, therefore, originally proposed in the pre-sales was Redshift, but as I mentioned at the beginning about the advantages of serverless and architectural principles, I thought the advantage of services is that we don't need to be paying idle costs. Let's look if we can use S3. So my idea was put it into S3 and then see how we're going to transform it. Initially plugged in Lambda functions, plugged in Lambda with AWS step functions to orchestrate it, but then realized that getting this data, this raw data that was streaming in from millions of vehicles, needed to be organized into a data lake, so obviously used AWS Glue. At the same time, set up crawlers, an appropriate frequency, and worked with their data scientists on this, and able to create a data catalog. That data catalog can now be serverlessly queried by Athena. Athena can then also query that data lake. And you see all of this power of big data is all serverless. It's sitting on S3. Obviously then, I was able to plug SageMaker in to allow that capability for AI/ML, and QuickSight enabled the business to see, using standard BI tools and visualization, to see what benefit and what value there was in these various projects. Using, as you can imagine, following the automate, a code pipeline was put in, and code build enabled them also to get to a point where everything would be infrastructure as code, and various data sources could be created using step functions and Lambda transformations, depending upon what the business wanted. And that data, of course, sitting in S3, it can be transformed, it can be viewed at any time, and lifecycle policies can be put onto it so that it's appropriately archived. So you're in a situation where these projects, if they fly and you want to take them to production, it will instantly scale up. So here comes the elasticity. Obviously then, if we're looking at the engineering team, they would have something like Tableau that they would be used to, but equally it's not difficult at all, as I've already explained in the previous architectural diagrams, just to write a single page application and access those data sources, and they would have access to them. And obviously that's easy to do, and it can be entirely customized. So the outcome from this, it allowed the enterprise themselves to learn about the advantages of serverless computing. It was very flexible. It was certainly the perfect fit for these sort of exploratory projects that had an uncertain future. The elasticity obviously was available. The pay-as-you-go model was perfect, with business justification being key. If these projects needed to be shelved, they could be, but equally they could be looked at again in 6 months' time, a year, whatever. And as already mentioned, the successful projects can go to production immediately without redesign. That's the important thing. So just looking at the two architectures that we initially discussed, very, very similar. Next, I wanted to explore myself, the best of the best. I'd seen that all the benefits of building these serverless architecture and how simple it was. But I wanted to look into utilising other public cloud services that are available as well. So the fact that the cloud is API driven, I knew the integration would be quite straightforward. Obviously, security would be important because now with the integration between two public clouds, you need to ensure that. And as I said earlier, making sure you factor that into every layer and every step of the design is critical. But now it opens up the ability to have no design limits, no feature limits, and no budget limits, because you really can choose what you think is the best for your designs. So I decided to do a proof of concept. I had a website, KEEP.FIT. I thought that I'd get all the toys out of the toy box and play, and during that, learn. And it goes back to that DevOps philosophy earlier. The more you start experimenting and the more you get the opportunity to try out these services, the more you learn, the more you'll be able to optimize, and then you get to the point where you're innovating. So again, the architectural pattern looks very similar. The only big difference here being, of course, that now we've got Google to the right. I knew that some fundamentals, I needed a website out there, and it would be pretty nice if someone could have, I don't know, John at KEEP.FIT. So I had to get some sort of email integration in there, and I had to get a website up and going. So this was quite straightforward. CloudFront was going to go in, API Gateway was going to go in to give me a logic layer. I was going to use Cognito to be able to secure that. I was going to have the ancillary services in there. I was going to split my assets and my prod and my dev account. I was going to put in a pipeline and make sure that everything was infrastructure as code. Then for more detailed logic, I would ensure that I could orchestrate that through AWS step functions. I would enable the process data to be available through static assets and take advantage of CloudFront with the high TTLs. And yeah, going back to that, leverage different data storage options. Of course, when you're working with CloudFront, it doesn't really matter what's going on at the back end. If you've architected that correctly, you could be running any fast database. As long as you're caching it correctly, you're still getting the results and speed you need. Best of the best, needed a third party. I needed to get information to this data, into this website, so I used a third party web crawler. I knew that I'd like to be able to get data from wearables. It's a fitness site, so let's allow people to monitor themselves and others and compete and challenge each other. So how was I going to integrate wearables? Well, I've been through this before. Let's just go through API Gateway and ensure that it's appropriately authorized, store that data via Firehose, and then stick it into S3. Now I started to follow the pattern that I'd seen before. I started seeing if I could work on that raw data with Lambda, using AWS step functions to orchestrate it, and hopefully create a data lake. So use AWS Glue. We've seen this pattern before. But it started to get quite complex. You see, the enterprise that I was talking about earlier had world-class data scientists. And this is a startup, this is me, and a developer, neither of which are data scientists. So I took a step back. This is starting to get a little bit complex for what it's meant to be. And I looked at GCP, in fact, BigQuery. Now, I'm just I hesitate for a moment there because you'll see that, hopefully, which is not very clear, AWS Secrets Manager. You see, it's nice because there's not an icon for it at the moment. That means that I'm pushing the envelope, so that's good. But AWS Secrets Manager, link that in with Lambda, and you're able to authorize BigQuery. So you'll see the pathway here now through to GCP, BigQuery, cloud storage. I didn't really need to use cloud storage apart from the proof of concept because I could actually link, and here's where security comes in, I could link my raw data into BigQuery and have that as a way of having the integration of data straight into BigQuery. And has anybody used BigQuery here? Just the one? Maybe a couple of people? Yeah? It's fantastic, right? I mean, you can throw stuff at it. It follows this serverless If you haven't tried it, really, give it a go. You can go through the console and try it out. You can upload data sets to it. It's amazing. And it's probably what's powering the Google search. It's massively columnar. It's parallel processing. You throw anything at it. It's truly serverless. If you compare that to Redshift, who's the winner? On startups, it's absolutely ideal. So here's the integration pathway. It's a lot less complex now, but it's got all the possible benefits of having world-class database services behind it. So then I thought, well, I need email. I looked at AWS Workmail, and that didn't fit the bill because has anybody tried that? Okay, so AWS Workmail has its challenges. I mean, I'm a huge fan of AWS, but the Workmail itself wasn't really the best solution. Whereas Gmail and G Suite with the G Suite applications, etc., is fantastic, and again follows the serverless model. So I looked at doing the integration with Gmail and G Suite, which was quite straightforward. So in terms of optimization that I was talking about earlier, and firstly looking at different data storage options, I tried Dynamo, I tried S3, I tried AWS Glue, I tried data lakes and Athena, but I realized that I was overcomplicating it. All I needed to do, although S3 is fantastic, and I managed to find just the right solution for this particular enterprise. For my solution, using GCP BigQuery was perfect. It made things a lot simpler, and it just took the integration of AWS with GCP. Now, I did suffer, if we go back, I did suffer from a bit of latency because obviously we've got that pathway. So again, I tried to resolve it in a traditional solution, traditional way by putting Elasticache in. I was using Redis and ensuring that I could cache those results, and that worked really, really well. But it cost a lot of money, so I went back to AWS. I'd just like to say this isn't a plug, but I did go back to AWS. I said, look, this actually costs quite a bit more than I thought it would, and they refunded it because they'd seen the pattern. So the customer service is excellent. How I actually solved it, though, was in a much more simple way. Angular, have I got any developers here at all? Anyone familiar with Angular? Yeah, great. So lazy loading, right? So this SPA was delivered. It was cached and delivered. Now, the user is able to scroll through various pages that have been delivered to their browser, and in the background, it's loading the query of the directory. In this case, what I was trying out was personal trainers, and you can have a look at the site. It's still a proof of concept, but you'll see it's all working, it's all serverless. So lazy loading meant that this query might be taking anywhere between 5 seconds to 12 seconds, but you haven't got to the personal directory button yet. So it's loaded it in the background, and it's cost no money. So again, what else did I learn? AWS Workmail. It wasn't great, and it was hard to work with. So why go through all that stress? Just you've got that integration pathway in that I was talking about with AWS Secrets Manager. You do that correctly. With Workmail as well, you also need OAuth as well, but it's really, sorry, with G Suite integration, it's really easy to do. And once you've set up integration in the first place, you can bolt on the best of the best. So the outcome with KEEP.FIT, it's entirely serverless. It uses public cloud integration. The Secrets Manager, as I've just mentioned, actually, yeah, it was the key to the integration between Google and AWS. You could do it in other ways, but that works, and it's nice and straightforward. And part of the architectural tenets earlier was keep it simple. G Suite integration works in principle. Unfortunately, as I'll say in a moment, I'll leave this to another slide. But with this being a proof of concept and very easy to set up, equally, it would instantly scale to enterprise proportions, as has been proven with previous projects that I've done. And that really is part of the beauty, to me, the elasticity of serverless. So just looking at the similarities between the architectures, the first one, the second, and then the integration. So in summary, Google Cloud Platform, BigQuery integration. Pros, it's world class. And as is their AI and ML as well. It fits the serverless model perfectly, no support overhead. You throw stuff at it and it will take it and it will scale and it will deliver. It's totally future-proof. Google are just going to, it's their flagship. It's wonderful, totally elastic, massively parallel. And I do believe, if you're looking at data storage, that is something that's worth looking at. Unfortunately, it's early days, so technical support's very expensive. And I've got to be honest, Google just aren't as customer satisfaction focused as AWS in my experience. But they have got amazing products. G Suite integration, pros, to me, it's the best email solution out there, and it fits the serverless model perfectly. The cons, at the moment, it's early days, so this public cloud integration, I know we do use different services, but actually architecting it from the beginning to think, I'm going to use the best of the best, is early days. So it's very hard to get financial support, and I tried. I went to the top, and they will only offer a 14-day trial, unfortunately. There's no funding for proof of concepts. G Suite is a different business unit at the moment from GCP. Technical support's non-existent because nobody's doing it. Although the integration is very easy, so you don't really need it. But it's been nice. In summary, early days. I don't think Google's ready to support integration of G Suite really yet. Hopefully that will change because it really is excellent. AWS integration, pros. Well, I think personally it's class leading. Their range of services. Almost everything AWS offer is outstanding. I stand by that. It really is great. The customer service as well. I've had nothing but wonderful things to say and experiences from their customer service, as is the technical support. I'm not plugging them. It's just I use them a lot and they're really, really good. The cons, I think, now, that their actual big data offerings, if you're not a data scientist, they can be a little bit complex. They'll do anything you want to do, and they are wonderful. But at the moment, they're a little bit complex to use. And startup funding is a little bit challenging. But that's to be understood, I think, because otherwise, everyone will be trying. And workmail, not so good. But as a general cloud provider, I see AWS as, really right there at the top. So, one of the summaries here, the future, I think it will always be a balance between the main cloud providers, and that's very dynamic. And I think if you look at architecting in public cloud integration, you're in the driving seat because you can say, I'm going to use that because at this present moment in time, and for the foreseeable 6 months at least, that's going to be the best. You can quickly use it. You don't have to be stuck with what you were using earlier. And if you're sticking to this DevOps and agile approach, it's not going to be difficult to make the changes. Again, same thing. Every 6 months you could be making a different design decision, but rather than be stuck in that cycle of, well, we made this decision, we're going to stick to it. If you put integration in initially, or the ability to integrate initially, then you can change as the new services from the different cloud providers become available. So I'd say be brave, rethink, re-architect, get your hands dirty, try it out, go serverless, challenge everything. It's the way forward. It's all there. There's loads of toys to play with, and it's a tremendous time. Public cloud integration, as I've just said, it gives you the choice of using the best of the best. KEEP.FIT, have a look. It's a good example of a proof of concept. The features can just be bolted on. It's entirely serverless. What I really wanted to get across, though, is that these startup serverless projects will scale to enterprise level and enterprise workloads. And serverless is very cool. Thank you very much.